Alright, this video is on simplifying expressions. This is a very basic lesson, appropriate for the beginning of Algebra 1. In this video, we're going to be discussing order of operations and combining like terms. Alright, just a quick review. The order of operations, symbolized by PEMDAS, stands for sort of a priority list. So priority 1 is to clear parentheses. Priority 2 is exponents. And then we have multiplication or division, depending on the order in which they occur. We always want to move from left to right. And last, we have addition and subtraction. And again, depending on the order in which they appear, we want to move from left to right. Please understand that order of operations were not handed down on Mount Sinai to Moses. These are conventions that were agreed upon by mathematicians. I believe that they're standard around the world, but I have not confirmed that myself. So order of operations, these are acceptable standards. You follow them or basically you fail algebra. This is just what's agreed upon. Now, combining like terms, it means we add or subtract terms that have exactly the same variable part. So for example, x squared terms are added to x squared terms. X terms are added to x terms. ABC terms are added to ABC terms. Okay, so the variable parts have to be exact with the same letters and the same exponents on those letters. All right, we're going to start with some arithmetic problems. Arithmetic expressions have only numbers, while algebraic expressions have numbers and variables. So our first arithmetic expression is -6 plus 12 divided by -3. Well, I see that I have an add and I have a divide, and according to order of operations, division comes before addition. So I have to do the division first. So I get -6, and then I have to divide +12 by -3. 12 divided by -3 is -4, so I'm just going to write -4. -6 minus 4, so I'm already 6 in the hole, and I dig 4 feet deeper, so now I'm 10 feet in the hole, so that's equal to -10. All right, our next example, also arithmetic, is 23 minus 3 times 5 all over 4. When you have a fraction bar, it sort of acts like parentheses. So when you see a fraction bar, you should think of the numerator and denominator as being in parentheses. The fraction bar acts like a grouping symbol. So we're going to work on the numerator first. In the numerator, I have a subtraction. I also have a multiplication. Well, according to order of operations, I'm supposed to do the multiplication first. -3 times 5 is -15. This is all over 4. And then, since I am visualizing those parentheses around my numerator, I now work inside those parentheses. I have 23 minus 15, which is 8, still over 4. And of course, 8 divided by 4 is 2. And I'm finished. All right, one more arithmetic example, or arithmetic example. -24 divided by -8 times 3 plus 4 squared. Now I want you to notice our operations here. Our operators are divide, multiply, and add. According to Please Excuse My Dear Aunt Sally, multiplication and division are on the same level. So the rule, the consensus, is that we go left to right. So this problem is telling us to do this division first. Negative 24 divided by negative 8 is positive 3. Now I'm going to recopy times 3. I'm going to recopy plus 4 squared. Now I have multiplication and I have addition, so I have to do the multiplication next. 3 times 3 is 9. Now I can safely do the 4 squared is 16 because the plus sign sort of separates the multiply and the squaring parts of the problem. And now I have 9 plus 16, which of course is 25, and I'm done. Okay, so our next example will be algebraic. 4 parenthesis 2x plus 3 close parenthesis minus 5x. Okay, well, according to Please Excuse My Dear Aunt Sally, I'm supposed to work inside the parentheses first. Now, you look inside these parentheses and you'll see that you don't have any like terms because 2x and 3 are apples and oranges. They can't be added to create one specific term. So I can't actually do anything inside the parentheses. So what I'm supposed to do now is move on to this multiplication that's understood between the 4 and the parenthesis. Now, we're going to use a rule called, or a property called, the distributive property of multiplication over addition. So that means the 4 gets multiplied by both the 2x and by the 3. 4 times 2x is 8x. 4 times 3 is positive 12. Notice the plus, the addition is preserved. I'm going to recopy the minus 5x. Now I have no parentheses. I'm left with addition and subtraction. I'm supposed to work left to right, but when I look at the first two terms, 8x and 12, I realize they're not like terms. So mentally, I use the commutative property to switch the 12 and the minus 5x so that the 8x and the 5x are side by side. Now they are like terms, so if I have 8x's and I take away 5x's, that leaves me with 3x's. So 8x minus 5x is 3x. I recopy the plus 12, and because they are not like terms, I recognize that I'm done. I can't simplify that expression any further. Okay, so we're going to do another example of an algebraic expression. And I want to use blue. This one is 2ab minus 5ab plus 6a. Notice this expression has two variables. That's fine. Remember that like terms have exactly the same variable part. So 2ab and negative 5ab are like terms. 6a is not like them. So the only simplification I can do is to realize that if I have 2ab and I take away 5ab, I'm taking away 3 more than I have. So 2ab minus 5ab is negative 3ab. And all I can do is recopy the plus 6a and then recognize that I'm done. I don't have any more like terms. I can't do any more simplification. Okay, and one last example. Negative 2, open parenthesis, x squared plus 5x minus y plus 7y, close parenthesis. Okay, well, parentheses first. So I'm going to look inside the parentheses, and what I'm looking for are things that can be simplified. X squared and 5x can't be added because x is squared in the first term and x is not squared in the second term, so they are not like. However, negative y plus 7y, those both have just plain y, so they are alike. So I can actually do that simplification. So I'm going to recopy the negative 2, the open parenthesis, the x squared, and the plus 5x. And now I'm going to say, okay, I have negative 1y plus 7y. Remember that invisible 1 right there. Take away 1 from positive 7, and you get positive 6y. Notice we still have the parentheses with the negative 2 out front. Now we're going to use the distributive property that allows us to distribute multiplication over addition. Negative 2 times 1x squared is negative 2x squared. Negative 2 times positive 5x is negative 10x. And negative 2 times positive 6y is negative 12y. I no longer have any like terms, which means I'm done and I can't go any further. Okay, that's a very simple explanation of simplifying algebraic expressions. Thank you for watching.